discussed before, when you make a group and you can pick one who you want to be an actor, a pawn character, a paper character, many different types of classes that you can choose from that all have certain things implemented. So again, we are going to use this time not just a paper character, but actually a PaperZD character. Because in the last video we did install the PaperZD plugin, and this also comes with a PaperZD character class that has all the components built in that we need to work with PaperZD. On top of that, we are then going to create our own inheritance, right? So we will create a VP dungeon character base, and from this, we can then make our own children, right? So we want to have some shared functionality between the hero and between the enemies. So we will need this shared parent. Now, some people think inheritance is outdated and it's bad, and you should use only components instead. But actually, that is not true. You will use a mix between inheritance and composition, which components refer to. And we actually are going to make a health component later on, which will be shared between the hero and the enemy. And yeah, we are going to be using both inheritance and composition card components. And just as a quick overview, the dungeon shard base will inherit from the PaperZD character as shared parameters that we can change depending on the hero and enemy. We're going to put the health component on with stun, knockback, sprite flash, and all of these things that we want both the hero and the enemy to be able to do. Now then for the hero, we have some special things that the enemy doesn't need, like the camera, player inputs, access to the HUD, and unique actions, like unique attacks and things like that. Now for the enemy, we will have different enemy types, but there are a lot of, most of the things are actually shared on the enemy base. And I do like to put this dungeon shard underscore base, enemy base. Now this is not the official naming convention. However, I want to make it very clear that these are only base classes that you're actually not supposed to use in the game. These are just for our structure. And the ones you actually put into the game is the BP hero, the skeleton, and the board. Now, on the BPM base, we have things like the despawn function, following the player, hurting the player on touching, and it's connected to the spawn system. On the skeleton and on the board, well, all we actually do is we put a different sprite for the flipbook. We put different flipbook in there. We set different health amounts. The skeleton should have more health than the board, but the board should be faster. So we actually just change parameters, but you could do a thing where a certain enemy has a different attack. So you could have a whole different function here for that as well. And just by the way, the program I'm using here is called Figma. It is free, and I would like to use it for things like this to just visualize the inheritance before I get started to get a better idea. Now back in the other product, this is where we left off last time. Let's get the content drawer to the content folder to make sure we don't have any filters active. To the blueprint, we have to right click and make a new folder called characters. And this is where all of our character blueprints will go in. And like I said, we're going to start with the dungeon chart base. So you can right click and click the blueprint class, and it is going to be not on here, it is actually going to be all classes. And we can just look for paper. And here we can see the paper is last time we used the paper character. This time, since we are going to use paper Z, and we're going to go to how we create our class of look, we are going to use the paper Z character, and then click on yes. And this one is going to be called BP underscore dungeon chart underscore base, because this is just the base class. And now let's just make it the hero right away. So we could go here with the different classes and look for a dungeon chart, right? So we do have our BP dungeon chart base here. So you could just select this and make a class from here. But we can also just right click it and create a child group and class from this. And it's going to be BP underscore new word. And just control shift S so you can make sure nothing delete. Now let's start with the dungeon chart base, because the basic things we want to set up right now, like putting the sprites and the angle, that should work with both the enemy and the hero. So let's open up the BP dungeon chart base. And this is very similar to the paper character that we used last time, right? So we do like a movement. Nothing has changed. The only thing that the PaperZD character has over a paper character is the animation component. And here we can pick the PaperZD instance and which is the render target, which is going to be sprite, right? So what do we want these animations to apply to? Well, we do want to take target sprite. And this is really everything that is new, relevant, different. And we're going to get into that later, but now we just need to set up the same basic things we did last time. Now first, we just want to set up the sprite, and here we just pick the sprite over here as a stand-in, as a reference. So for the source sprite, we just come here and give it hero idle, and I want hero idle down as the default, right? And you see that the scale already looks good, right? Once we flip over. So we actually want to go with rotation on the red x-axis from 70. So it's the top one there. And you can see the collision actually looks pretty good already, right? If the scale on the side is always fine because we always get up the pixels per unit set. And now we make these changes to the DP boundary to our base. We want to make sure to compile and save. And if we now go to DP0, since it is for data, all of these changes apply. We do have the sprite here now, and we do have the rotation that we put in the parent. So this is how inheritance works. We do have the option to override all of these things. So we could set a different rotation here. We could set a different sprite here. And like this would give us a default value we pass down, and we then still have control over it and make changes. Now we do have to spawn this BP0 as a default pawn. And we already in the content drawer blueprints have set up our GM dungeon, our game mode, and we did tell anyone who is probably going to use this game mode. So we just need to open it up. And you might get this kind of closed down blueprint view, the short view. You can open up the full blueprint editor. You don't have to. But this is just the one you see most of the time. This works then. And for the default contract, we then want to select our BP hero because the hero is our player character. And compile save, and I can go back to the map and I can start the game because we have this player card here that we put in the last lesson. Well, the Unreal Engine does know where we want to spawn. And you can see that we are spawning in the correct position, but well, we cannot move. I click in, we cannot move. We don't see the character. But actually, if I press Shift and F1, I get my mouse back, then I can eject and then hold the right click and move around. You can see the character is actually there. It is properly spawning in the hero. But we don't have a camera on the hero yet, so that's why we get this weird first person view. So the first thing we want to do now is to not go to VP Dungeon base, but in here because only the player character needs a camera. Select the capture component again. We want to use it turn on. And if you have anything select it, we want to add the regular camera. Now again, on the screen now, we want to look at the character from the top. So we put in the rotation on the Y, the green one to 70, And also the Z, the blue one, get 70. And you can see that with the handle on this side, we get the blue arrow pointing upward, and this is how we know that we have the correct setting for the rotation. And again, we do want to go to the screen and do the learing test and find it out. For 3D games, if it's nice, if you have rooms, but again, for 2D games, this might just cause issues. And get out of the search, and on the camera, we want to use not the perspective mode. Like I said last time, we want this kind of 2D look, the orthographic, orthogonal look that has all that sucked out of the scene. And we go to projection mode, orthographic, and you can see that we have this ortho width of 1500 something. And this is our zoom level. And we can just start the game now. And you see, well, we are possessing the character. We are looking through the character's camera, but we are very far away. So that in hero, we just want to go to the ortho width off. And I played around with it in front error. And I like the value of 800. And now if I start again, we are closer to the character, and this looks much nicer. Now, as the last thing in this video, we just want to set up our input, again, the enhanced input actions, and make the character move. And this is just a refresher, we've already done this, so we're going to be able to go through the playbook fast. So in the content drawer, content, right click, and create a new folder called input. We right click again, we make a new folder called actions. Inside of the actions folder, we first are only going to worry about the movement, and everything else that is happening we can later. So input with a single input action, IA move, open it up, and just like last time, because we want to be able to use the keyboard, the D-pad, and also the analog stick, we want it to be an axis to left, right, up, down, a vector to D, and save, and back at the content row, we go to input, and we want to create a input mapping context. So again, on input, we have the input mapping context. I'm going to call IDC dimension, click on that, and we just have to bind our movement action. So instead of none, click on IA move, and we'll have to set up the buttons again. You can try to challenge yourself to pick the correct modifier, so I would like you to try that if you remember from the last video, but I'm also going to go through it with all of you. So if you just want to try it yourself, you can pause right now, give it a try, but yeah, we're going to do it again. So I just want to set up WASD controls, and again, the default is right on the horizontal axis, so I'll just use D for here, D on the keyboard. We don't have to change any modifiers. Next up is left, so it is A on the keyboard, and this is still on the horizontal axis, so we just need to negate. So we need to negate modifier here. Next up, we want to downward S, and here we need the swizzle. But downwards is positive, right? It is the positive y value. We only see it. And lastly, it is positive. Up is really to two modifiers. So we swivel or going from the horizontal to the vertical axis, gate from downward to upward. And safe is exactly the same thing we did last time. Yeah, I think this is something always been better for it. And now that we have this, we actually need to carry the here to it. And like last time, we go to the event graph, we begin play, and here we can then just get controller, cast two, layer controller. And again, this is a cast, you get the hard reference to the player controller, but it's not a big deal because the player controller exists in many already anyways. And here you can switch subsystem, get enhanced input local type subsystem, and just add method. Okay. And make sure to not forget these execution things. And then here we need to select our path and dungeon and we have to have the way of cells. This is it for setting it up, so it's registered and play, it's not safe. And well, we need to put in our input type to have IA, and here this has action events. And this is going to be exactly the same as last one, so we have the break action value, so we have both the x and y axis. When triggers, you take every single frame this button is being held, we want it to fire up. Use the input here, and we can have x as the scale value. World direction on the x is a 1 because we want this to be right and left. And then just copy paste, Control C, Control V, the next to the execution thing. And here we use the y as the scale. Again, this will be a value between -1 and 1, which can tell us where and how we walk. And then here, world direction on the x, make sure to put this to 0. And on the y, we want to put down after the jump. Make sure to click into the viewport, otherwise you're not going to control the game. And now we can press WASD and walk around. But in the end, we want the map to be roughly the size that we have now. So in comparison to that, the character is very, very fast. So we can do this in the dungeon chart and here because well, we want all characters to be slower. And you can still do character movement component and look for max walk speed. Yeah, this one, and we have 600. I want to work half, so I can put it 300 centimeters per second, but it might actually get shown as 3 meters per second. This is fine. And compile and save. And back in the map, I can walk around now, and this feels more like a top actual dungeon. And we carry can now move, and we're just playing the idle animation. We still need to switch between walking and idle, and we still need to actually set the directionality if we walk right, if we walk left. And this is actually going to be different than last time because we will use PaperZD, which makes it so much easier. We've come to the point where our character can move around, but we're not switching between the animations and we're not setting up the directions. And that's what we're going to do this time. But we're going to use PaperZD, which makes it so much easier than it was in the last chapter. Outside of allowing us to set up multi-direction animations, PaperZD also has many other benefits that you're going to see over the next couple of lessons. There is a little bit of a setup process though, and we're going to go through all of that and we'll create multiple assets. The first thing you always need is an animation source. So when you come to draw, I like to put it in the same folder as the group and for the character. So grouping characters, want to migrate the folder for the hero. So new folder, hero, and I'm dragging here, here, out right here, and look for paper Z, not paper B, paper Z, and then the animation source. That's for animation source underscore 3. Then double click open this time. And this is basically the place where we register all of our flipbooks, all of our animations. We can set up anim notifies, and then everything that is registered here, we can then use in the animation blueprint, which we're going to create. So first, we want to add a new animation sequence, which we can do by clicking on Add New. And just a new animation sequence. First one, I'm going to call idle. Enter. And while we have this selected on the right side, we can then select our animation data. For example, we just go for video idle, and down, which is the default. And in here, we can also zoom, we can right click to drag around. And at the bottom, you can see that the animation is playing all the two frames that it has. But that's not all. There's a very simple way to set up multi-directional animations just by clicking this checkbox here. And now we turn this animation into a multi-direction animation. And we might want to drag this over to a better top editor here. Now we need to set up every animation for every direction. And by default, we have four here. So we have up, down, left, right, which is what we actually had in the last game. We can go all the way up to 16 and you see 16 directions. And this is actually not very common because it is a lot of work to create 16 directions for assets. We do see this sometimes, but it is not common. We could also change the angle here to like 45 degrees, for example, if we have an isometric game. And this just makes calculating the angle easier. But in our case, we just want to go back to zero and angle of zero. And our game only has, we can open up the content drawer and you can check the content, the paper assets, characters, hero. And in the case of our hero, we do have 8 directions. So you can see the attack, down, down left, down right, left, right, up, up left, up right. And we have 8 directions for every animation for the hero character. So we just want to set at the end the number back to 8. Now let's start from the top and go clockwise. For the top, we select anything in this area, and you can see right the animation changes. So anything in the top area, so then this is a bit smaller. So yeah, anything in the top area, if you click here, we can then select the animation node as 0, and this should be up. So 0, idle, view. For up, right now you can see we're playing the up animation. Now let's go clockwise and click on the next area here. And this is up right. So here is the hero, idle, and you are top right. Right, and you can see we can switch between these. And next is right. So hero I R this one. And then here it's down right. So hero I DR down right. And then here down hero I D. Here I down. Here's down left hero I DL. And this one down left. And then left hero I L. Left this one. And then up left hero I UL. And this is the entire circle, right? So now we finished the entire circle for our 8 directions for the idle animation. And one thing you can do to preview here is to hold shift, and then you can just move around the cursor and you can see how smoothly this works out. And this might be the stage where you want to go back to your editing program and change the pixel art if it doesn't look right. And with this system, we can just be switching the directions up to PaperZD instead of having the whole branching logic we had last time. And even though we only had 4 animations last time, it was already hard to keep track of. With 8 animations, it would have been twice as hard. With 16 animations, it would have been even harder. So even though we do have to go through this process of setting up the animations here, the directions, it does take some time, but in the long run, we are going to save a lot of time. And now we only created a single animation. In the next video, we're going to go through all of the remaining animations. It's going to take a little bit of time, but this is a setup process I want to get over with so we can then just work on using all of them. Now that you understand the concept and know how this works, we can just go through all of the remaining animations for the hero and later also take care of the enemies. We can just open up the content drawer and check again which animations we have. So we can choose the attack animation next because here. So just click add new animation sequence and we like attack. And very important, you need to make sure it is actually selected. You can double click this. Mistakes can happen if you don't activate it. And then you know again we want multi-directional animations, multi-directional sequence, 7 to 8. And again, we start from the top. So hero attack. It doesn't just show this one, it shows all the matches. And hero DR. Hero attack. DR. And down. Left. 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 This one. And up left. Up left. And yeah, that's it. Again, we can hold shift and go around just to confirm that we didn't make any mistakes, that everything matches up. And yeah, so this is a little bit a long process. Like if you do this on your own game, you can just watch YouTube on the other screen and just go through this. So I hope that maybe we can get some quality of life improvements to PaperZD to just right click all of the flipbooks and maybe add them here. It might be very hard to implement technically, but that is how I imagine it would make the setup process a lot faster. But yeah, we're just gonna have to go through all of the remaining animations. You don't necessarily have to keep watching how I do it. You can just go on your own because you understand how it works now. But you can also just follow along if you're not so secure yet. And I'll just go through all of these, right? So with the attack animation, then it's gonna be the bow animation. So I'll just go here, new animation sequence, bow. Again, make sure to keep selected, multi-direction animation, 8 directions as always. Start at the top, zero, bow, up, back, right, here, far, up, here, zero, bow, zero, down, stuff done. And now we're just gonna make sure that you save everything, file saves. So this one you can close it down with A0. And actually you can see now in the characters, groupings, characters hero, the animation sequence folder. So every time we create an animation sequence inside of the A0, it actually creates an animation sequence asset for us automatically. And yeah, just so you know that this actually gets created. So now characters, we want to, we haven't created the blueprint yet, but we want to make a new folder for the board and also make a new folder for the skeleton. And yes, let's start with the board. So again, go into the board folder, right click, we go to PaperZD and create the animation source. It's going to be AS underscore board and double click open it up. And yeah, so we only have a walk animation on the board. That's all we have. So we just go to add new and add animation sequence. And you might have to right click in the name and call it walk. Make sure it's selected and go to move direction sequence. And like I said, in this case, we only have 4 animations. And you might think it's weird, like why does the character have 8 and why do these have 4? Well, it just simply comes down to the effort it takes to create an 8-directional animation. So of course it would be best for everybody in the game to have 8 directions to not cause any inconvenience. But in reality, there's a lot of enemies in most games, and you don't have the resources to create 8 directions for all of them in most cases. So there are actually some cases where, so there are many games where the character is of course the most important. So you can afford to create the assets for 8 directions, but you just can't afford to do that for 100, 200 enemies. So it's actually quite common to not use the same amount of directions. And now you just select the top one and look for board, and you can see board walk up or up, and we might want to zoom out of here. And I'm not sure why the board is blurry here. Let me just check the assets if we have to apply the texture settings. Content, go to paper assets, characters, board, textures, and I open this up and I zoom in here. So no, it actually looks crisp here. So I think this is just actually okay. Yeah, it was just some sort of bug. I don't know. Now it's showing up fine. Yeah, let's just keep going. So on the right side, I want to board walk, R right, down, that can be board walk down, and left that can be board left. Right, and then hit shift again, and you can switch between. And then we can save, go out of here, and do the same thing for the skeleton, right? So this is very easy, very quick. So blueprints, characters, skeleton. So yeah, see you in the last lesson, we set up the animation source and the animation sequences which we need for the animation blueprint. And the animation blueprint is exactly what we're going to create in this video, which then allows us to decide when we switch to which direction and when we switch to which animation. And we're going to start with our hero character. From content drawer, we go to blueprints, characters, and hero. And here we want to right click and our PaperZD. We've used the animation sequences, we've used the animation source, but the last missing piece is the animation blueprint, the PaperZD MVP. So we can just left click it, and we now need to select the animation source, which should work with this animation blueprint. And since this is for the hero, we want to use the AS hero, right? And now we call it AVP underscore hero. And by picking this AS, the animation source, like all the animations we prepared here are now available inside of this animation loop. And we can just double click to open it up. And if you've worked with skeletal meshes, if you've worked with 3D animation blueprints, all of this looks very familiar. So we do have the hero, and here we want to right click and our PaperZD. We've used the animation sequences, we've used the animation source, but last missing piece is the animation blueprint, the PaperZD MVP. So we can just left click it, and we now need to select the animation source, which should work with this animation blueprint. And since this is for the hero, we want to use the AS hero. Right, and now we call AVP underscore hero. And by picking this AS, the animation source, like all of the animations we prepared here are now available inside of this animation group. And we can just double click to open it up. And if you've worked with skeletal meshes, if you've worked with 3D animation blueprints, all of this looks very familiar. So we do have the event graph here. So when this animation blueprint instance starts up, it's initialized. We have the event on it. So here we can set references and the other things. Event on tick is on every frame. If you need to update some data, you can use this. And this is, again, it is very similar to how it works with 3D skeletal meshes. And then we also have the animation graph, the anim graph over here. And this is where we set up which animation should play at what time, the transitions, and all of these kind of things. Now let's start just with a very simple example of how we can use this. And well, whatever animation we put in here is going to be playing. So we can just start with something very simple. We just grab it here and play. And you can see all of the animations that we registered, right? You even at random sequence, just play a random one. But we just want to play the walk animation for now. And yeah, this is it. We can compile and save. And you can see that if this is active, we're just going to play the walk animation for now, right? So I'm going to drag this over here. And well, if I start to go now, nothing happens, right? Because we still haven't pulled the hero's blueprint to actually use this animation blueprint. So in the content drawer for the DP hero, we do want to go, well, just to the viewport for just to get a better overview. And in here on the left side, the animation component, right? So this is something you get from the PaperZD character. And this takes care of, well, how these sprites, how the blueprints work together with the PaperZD animation blueprint. And we just have to do something very simple, right? So we just select it on the right side. We have anim instant class. And it says none. So here we just have to select the ABP underscore hero, which is our animation blueprint here, right, that we set up. That's going to tell the character to walk, play the walk animation. And here you don't have to change the render component wrap. Well, this is going to be the sprite, right? We have the sprite here. So by default, this is already set up correctly to affect this sprite that we have here. Now, even if you combine state, nothing is going to happen inside of this blueprint, right? So it's only going to work inside of the actual game. So I go to map dungeon, I start the game, and you can see we are now playing the walk animation as we set it up in this animation blueprint. And this is just the first step to make sure that the connection is actually set up. It is actually overriding the animation we have on the sprite, and PaperZ is taking over. Now, the next step in complexity would be animation as we set it up in this animation blueprint. And this is just the first step to make sure that the connection is actually set up. It is actually overriding the animation we have here on the sprite, and PaperZ is taking over. Now, the next step in complexity would be to, again, the AVP hero, to just switch between the walk and the idle animation, right? And we're going to take it step by step so you can see all of the different ways this could be used. So we could simply go here and select bool. So select animation by bool, right? And here we can also right click again and play idle. And now we have both of these prepared here, and we have a switch and select animation by bool here. And what I want to do is connect the walk to true and connect the idle to false. And well, let's just say if I have this at false, right? So now this is false. So there's a literal, you can just set it here. I leave it at false and we start the game now. And you can see we are playing the idle animation. I go back in here and I tick this box, right? So now it is true. So we should play the walk animation. And we are now playing the walk animation, right? But of course, in reality, we want to have some sort of condition to set this while we are playing the game. So the easiest way to switch between walk and idle is to just check the velocity. So we can get only actor And this is going to get whichever actor or blueprint owns this animation blueprint instance, which in our case is the BP hero, right? So we get a reference to the BP hero actor here. We can simply get velocity, which is the speed and the direction the character is traveling in, and then get the vector length. And this is just going to give us the speed because we don't care about the direction it's going up, down, left, right. We just care how fast is the character going. And we can simply check is this bigger or greater than 0, right? So if we are moving at a speed faster than 0, we play the walk animation. If we are moving at a speed slower or exactly 0, we play the idle animation. Simply check is this bigger or greater than 0, right? So if we are moving at a speed faster than 0, we play the walk animation. If we are moving at a speed slower or exactly 0, we play the idle animation, right? So I can come down, say it, and go here. I'm not touching anything, we're standing right, but then I walk, and you can see the character is moving, and the animation is switching to the walk animation. And this is just a very simple way you can set this up using a select animation by board. And we're going to expand upon this later by using a state machine. But for now, I'm just going to open up some space here and show you how we can set up the directionality. Because now the character, even if I go right or left or down, it's not changing the direction. So in here, after we decide the animation, it should be before this output animation, we can just look for directionality and set directionality and connect this up here. And we have a vector 2D. So with the x-axis and the y-axis here. Now, for example, if I want the character to point to the left, right? So that would be a -1 on the x-axis and a 0 on the y-axis. I can just go here and you can see the character is always pointing left. And another example, I could put the x to 0 and put the y to 1. And where are we going to point now? Are we going to point up or down? And the answer is probably going to confuse you, but I start now. And we're actually pointing up. So this is a peculiar case because, well, in Unreal Engine, in the 3D space, we see that the y-axis down is positive, but actually the directionality works in 2D space. So if you have a 2D game or a UI element, then x positive is right and x negative is left and y positive is up and y negative is down. So later, once you plug in the actual information, we're actually going to flip the y-axis to kind of convert between the 3D and 2D space. And well, now we are pointing up, and we can also point up and right, for example. So x1 and y1 should be pointing up right. So you can see we are now playing up right animation. And again, we do of course want this to change dynamically while we are playing the game. But this was just an example to show how this actually works. And to set this up dynamically, we actually want to save the last input we gave to the player. So in the BP Hero, in the event graph, right, on the event graph, we have the and IA move event. And you see we get this vector 2D structure. And this also takes in a vector 2D structure, right? So we just want to save this every time the button has been triggered or pressed. So we can open up a little bit.
I hate it when I get distracted and miss the whole video.
Kind of convert this
I do it too much.
And well, now we are from up, and we can also point up and right, for example. And again, we do of course want this to change dynamically while we are playing the game. But this is just an example to show you how this actually works. And to set this up dynamically, we actually want to save the last input we gave to the player. So in the BP Hero, in the event graph, right, in the event graph, we have the IA move event, and you see we get this vector 2D structure, and this also takes in a vector 2D structure, right? So we just want to save this every time the button has been triggered or pressed. So we can open up a little bit of space here, and you might already know this, we drag off and promote to variable, and I'm just going to call this direction now with here, and connect it here. And of course, you could also just create a new variable here first and drag it in, but the multi-variable is much faster. And make sure all the execution points here are connected. Now, every time we have an input from the keyboard or from a controller, we first save the directionality, and it's going to give us an x and y axis, and then we're going to add the movement. But now we need to access this directionality inside of the ABP Hero and pass it in here. And now how do we get this directionality, right? So we can get the only actor, which is a reference to the BP Hero, but if you drag up here, you cannot get the directionality because, well, it is just an actor object, right? It doesn't understand that this is of the class BP Hero. So again, an easy way is to use cast from here, cast to BP Hero, right? And well, the cast could fail. We could check for the success or not, but well, we know it's not going to fail. So we can then just use the as BP Hero and we get the directionality from here. So we can get directionality because, well, we now understand that this is an instance of the BP Hero class. And like I said before, well, if we just plug this in directly, we're going to have some problems, like we go here. Left and right actually works correctly. If we just plug this in directly, we're going to have some problems, like we go here. Left and right actually works correctly, but up and down is actually flipped. Because like I said, we need to convert between this 3D and 2D space on the y-axis. And a very easy way of doing this is to just disconnect this line again, hold Alt, and left click the line. And we can then break the directionality like this. And on here, we can split the spectrum. And for the X, well, we just connect the X as is. There's no problems here. And the Y, we have to invert it. And how do you invert a number? Well, we can just do multiply and multiply by -1. So this is very simple math, right? So if we have a 1 input here, it's going to be multiplied by -1, it's going to become -1, and also the opposite way. And we can just plug it in here then. And if I compile and save and start again now, left, right, still working, up, down is also working now because we are properly inverting. And also a diagonal is also, it's going to be multiplied by -1, it's going to become -1, and also the opposite way. And we can just plug it in here then. And if I compile and save and start again now, left, right, but the -1 is going to become -1, and also the opposite way. And we can just you're done. And if I compile and save and start again now, left, right, still working up, down is also working now because we are properly converting. And also, yeah, diagonal is also working without any issues. And now both the position between idle and walking and all of the directions are working, and this is fine, but I do want to clean this up a bit because now we're still doing some things here that aren't best practice. And we talked about casting before. Well, having a hard reference between the animation blueprint and the DP hero is not an issue because, well, they're always going to be loaded at the same time anyway. They're always going to be in memory at the same time. So having a hard reference is not an issue. And the actual cost of executing this cast to DP hero node is not that high, but if we can, I do still want to only cast a single time. And I'm going to show you how to do this. This is my personal preference. It is a very small tweak. You probably not going to notice any performance difference unless you have hundreds or thousands of characters using this. But I want to go to the event graph, and on init, we know that this animation group is initialized one time when it is loaded, and we do already have the reference to the owning player at that point, right, to the owning actor. So we have these, sorry, I'm back here. In the anim graph, this get only actor, we can just copy it. And here on the idle, well, we can just also look for get only actor here again. We're going to copy it. And this, I just want to cast with, cast to the hero, right? And so now we're only going to cast a single time and init on the init of this weapon instead of casting every single frame that this is a value. So in the event graph after casting, we then have to save this reference in a variable, right? So to look a variable, and I'm going to call owning hero. This, and I'm just going to select everything Q to line them up and bring this one down. Actually, I don't like the way these line up, but yeah. So now in the anim graph, we can make sure that, well, we don't need to use this cast to. We just drag out the owning hero, get it, and just going to select everything Q, cast it, cast to the hero, right? And so now we're only going to cast a single time on BP init, on the init of this looping, instead of casting every single frame that this is a value. So in the event graph after casting, we then have to save this reference in a variable, right? So to local variable, and I'm going to call it hero. This, and I'm just going to select everything Q to line them up and bring this one down. Actually, I don't like the way these line up, but yeah. So now in the anim graph, we can make sure that, well, we don't need to use this cast to. We just drag out the owning hero, get it, and use this direction. We can get rid of this node now and line it with this. And actually for this one, also, we don't have to get the owning actor. Well, this is not a heavy operation, but we can just use the owning hero here as well and just make it more clear what is happening here. And now we also want to clean up this upper part because, well, set animation by glue is fine for very simple things. We are going to make the pack animation. We're going to have other things added later. And if you want to have multiple animations, well, then this turns into a mess because, well, then we have to use another select animation by rule, and then we have to daisy chain from here again, daisy chain from here again, and it starts becoming a mess. So I want to use a simple state machine instead. So all of this, we can just get rid of it right now. And I just want to drag off from here, from the set directionality, and we can look for state machine, and we add a state machine. And the default one, I also like to call local motion. Yes, and yeah, I also want to drag this up a little bit, just make it look nicer, and line it up. Again, we can execute, because this is not a heavy operation, but we can just use the only hero here as well, and just make it what it is. Animation by glue is fine for very simple things. We are going to have the pack animation. We're going to have other things added later. And if you want to have multiple animations, well, then this turns into a mess because, well, then we have to use another select animation by rule, and and then we have to daisy chain from here again, daisy chain from here again, and it starts becoming a mess. So I want to use a simple state machine instead. So all of this, we can just get rid of it right now. And I just want to drag up from here, from the set directionality, and we can look for state machine and we add a new state machine. And the default one I also like to call locomotion. uh, This and yeah, I also want to drag this up a little bit just to make it look nicer and up. Again, we can execute the running all of this. And yeah, so now in locomotion, we get a state machine, which again is very similar to the one we had for skeletal meshes. And the animation starts here from out. And what is the first one we want to go into? Well, it is going to be the animation state for, and you can select this F2 or right click to rename, and I want to call this idle, right? Because the starting state is going to be idle. And now we actually need to set which animation to use. So once it is here, we can double click it. And here we have again this new output animation mode. And here we can just play idle. And we could set the play rate, how fast it plays, so we should play backward and all of these kind of things. But yeah, this should loop, right? The idle animation should loop. This is fine. And this is all we have to set in here. And we go back to the locomotion, and we now want to set up the walk animation as well, just like we did before. Drag up here, animation state, and we need it to walk. And again, here you want to go in and just play. And you could have in here, but again, have like select and by rule and do some other things. So maybe you have a walk animation with empty hands, maybe you have a walk animation for katana, and you could have nested logic inside of all of these nodes. But again, we just need the play walk animation from save. And now we need to set up the transition. Just like we did before with the condition, the boolean for switching between idle and walk, we want to do the same thing here. And a very common approach is to just use the velocity again, right? So when going from idle to walk, I just want to get the O0. I can get velocity all the way at the bottom. We get velocity and just look for length, the vector length. And we just want to check if this is bigger than zero, greater than zero. And yes, so in this case, we can transition to the walk and zero. And yes, so in this case, we can transition to the walk animation from idle to walk. And we now want to copy paste this with locomotion, and we also need to set it up from walk to idle. So what is the case that we can go back from walk to idle? Well, we just go here, we paste this, and it is the exact opposite. So I can just grab it here and look for not boolean, and this creates the opposite condition here. And you can connect it here, everything to Q to line it up. And this is the same thing we had before, idle to walk. And we now want to copy paste this with locomotion, and we also need to set it up from walk to idle. So what is the case that we can go back from walk to idle? Well, we just go in here, we paste this, and it is the exact opposite. So I can just grab it here and look for not boolean, and this creates the opposite condition here. And you can connect it here, everything to Q to line it up. And this is the same thing we had before, basically, but it is more future-proof because we can have more connections here. We can have more complicated logic in here instead of just having a single daisy chain of select and by here. And just to show you, we can go back here, right? So everything is happening here in the locomotion, and then we set the directionality. So just to show you, everything still works the same. It's just cleaner, it's just nicer. still works exactly the same way. Now, one last thing you might notice is that if I start the game, the character by default is looking to the right. And this can actually easily be set up. So in the BP hero, we have the directionality, right? So the variable for the directionality. And before we input anything, it is going to be 0, 0. And by default in PaperZD, if we have 0, 0 for the directionality, it's going to point right. So the way we can set this up is when we decide which direction we want to look. And I think the default for most of these games is to look down when you start the game. So down means, well, X, we don't have anything 0, but down for the directionality means in this case, well, it does mean 1. Because it is 1 in the terms of 3D space. Because we do still then take this 1 and multiply it by -1, right? So then it becomes minus. In this video, we're going to implement the character turning and direction. You might remember in the first game, even if the character would turn around, the attached collision box would not turn with the character, and this would make the collision detection less accurate. You couldn't really check if something is in front of us or if it's just around us. And since this game features combat, the collisions are going to be much more important, and we're going to come up with a good solution to this problem. Now, first to demonstrate this, I want to add the hitbox that we're going to use for our storage. So in the DP hero, we want to go to the viewport and for the capsule component, because it should be a child of the capsule component, click on add and look for box collision. This, and I want to call it hitbox. And well, generally speaking, the hitbox for the sword, it's going to be not exactly where our character is, but it's going to be slightly in front of the character, right? So we swing the sword downward, it should be slightly downward. This is going to be default direction downward, right? And if we then go to the hitbox and look for hidden and uncheck hidden in game and start the game, we can see the hitbox slightly, but even if I walk upwards, if I walk right and turn, the hitbox, it does not switch the direction, it does not switch the position. Because, well, our character itself doesn't really rotate. The only thing that rotates is the direction out in PaperZD. So what we're going to do now is to change the actual character to rotate so that everything that is attached to the character also rotates with it. And that way we can make sure the hitbox is always in the right direction. If we have particle effects, lights, and other things attached to the character, we can also make sure they're always in the correct direction. Now, there actually are a couple of steps to this, and again, you have to be careful to not miss a step because there's a couple of systems that are working against each other. And we have to set orientation towards movement on. We have to set use controller while to off because that would override the setting. We make sure the sprint arm does not rotate with the actor, and we make sure the sprite does not rotate with the actor. And then in the directionality, we can just use the actor forward vector, the actual rotation then. And we also can set the rotation with how fast the character rotates. And you might want to set a bookmark here, but I'm going to take you through all of these steps and we have to make sure that we don't miss anything. And some of the things we set up here don't just affect the hero, but they also affect the enemies that we're going to make later. So we do want to change some things in the DP dungeon chart base. And we can just go here to show it in the Explorer and double click to open it up. And you might just see this shrunk down editor, and we can just open the full editor here. Now, the first thing we want to change is orient rotation to movement. So while we have the top level select two, we can just look for orient rotation. And here we see orient rotation to movement. And this is part of the character movement. And we just turn this to on. And if you hover here, you can see that it says normally you want to make clear that other settings are clear, such as use control rotation yaw on the character, right? Because these kind of settings fight with each other. And this is what we're going to do. We can look for use controller. And you can see by default, we have use controller rotation yaw. We do want to turn this off so these two settings don't fight against each other. Now we can compile and save. And since this is a parent of the BP hero, op use controller, and you can see that it applied the settings here as well, right? Because we changed it in the parent, it changed it in the child, right? And this, everything we changed here is also going to affect the enemies later. And now back in the map, I can start, and things are going to get a little bit weird now, right? I press up, and everything kind of rotates. And well, parts of this is what we want, and other parts are what we definitely don't want to happen. And the way we fix this is by first making sure the camera does not rotate together with the actor, with the BP hero. And we don't have a character in the dungeon shard, right? So this is only the BP hero. So for the spring arm, because the spring arm is what holds the camera in place, we can go to rotation, and instead of relative, which means it's going to turn with its parent, which is the capsule component, we want to just ignore the rotation of the parent. And we can do this by setting it to world. And now it's going to show absolute rotation. And I can compile and save and go to the map. And you can see even if I move now, the camera is not going to turn with us, which is good, but the sprite is still doing weird things, right? And this is also easy to change. So in the BP dungeon shard, because again, the sprite is in the dungeon shard, it's going to be passed down to the enemy, it's going to be passed down to the hero. We want to do the same thing we did for the spring arm. So we can get rid of the search, and for the rotation, we do want the sprite to have a world rotation as well. And you can compile and save and go here. And now this is all this world the sprite in theory, the actual rotation is fixed in place, and PaperZD is the only thing that allows us to change the direction. And you can see that the hitbox starts moving with us. The direction is still a little bit messed up, but it is actually working with the rotation. Now, an easy way to fix this is to go to the BP hero, and you can see the arrow component, right? So actually the default
Curse of the Were Rabbit. Indubitably.
Is not the direction that the sprite is looking at. The default rotation of this entire actor is actually, and you can see if you zoom in here, this small blue arrow, right? So what we want to do is we take the hitbox, we just set it back to the zero location, and we actually want to drag it on the x-axis. Let's say we're 30, right? So I want a 30, 0, 0 for now, and compile and save. And now if I start the game and I walk, you can see that now it is slowly kind of moving into position of wherever we are placing.
Okay, I see why.
So this is kind of working now. It is correct, but there's a little bit of descent, right? You can see the little delay that we do want to get rid of. Now in the AVP hero, the animation for the hero, which is direction because now, well, we do want to just take the forward vector, the location that our character is facing at. So here, from the only hero, we can just get actor forward vector, and this is going to give us a vector 3. And the thing is, well, we only need a vector 2 for the directionality. We only care about the x and the y. So the way we do this, well, we can just get rid of all of these things here for now. And we want to instead just fix this up again.
A little restart might be nice. Got some of the kinks.
Let's get started making the hybrid RPG. And as always, we have to first create a new project. And I'm going to use Unreal Engine 5.4 and click on Launch. Once the project browser is open, click on Games, and we again want to start from blank and do everything from scratch. On the right side, everything is fine as default, and I'm going to name the project Hybrid RPG and click on Create. Once we're done loading, we should again see this open world map, and we're going to go through a lot of the same steps that we did for the other two projects. But since this is not a 2D only game, but a 2D 3D hybrid, there are going to be some differences. In this lesson, we're going to differences. First, we're going to create a new map to replace this open world map. So go to File and New Level. And this time around, we don't want to use the empty level because we do want to have a skybox, we do want to have lighting. So we want to use the basic level this time and click on Create. And as you can see in here, it's not just an empty map. We do have some ground to work with. We do have the player start. We have some lighting and other things that we want to use in our 2D 3D hybrid. As always, we now want to save this map and then also make it the default for the file, save the level, and in the content folder, click, make it maps folder, open it up, and I'm going to call it map all caps and call it play because, well, this is not going to be our actual map. This is just for testing, for setting things up. And we're actually going to import a map later on. So click on save. Now we first want to set up the game mode again so we can set it together with the map as the default values. So in the content drawer, go to the content folder, and here right click new folder and call it blueprints. Go here, right click and create a new blueprint class as we have done many times. And it should be based on the game mode base, which we want to extend. And I'm going to call it GM underscore RPG. For now, we don't have what we want to set here. We just want to set this as a default so you can later make changes easily. So again, go to Edit, Project Settings. Here and for game mode, we just want to set our GM RPG. And for the startup map, we just want to set our map playground or the default map as it's map playground as before. Next up, we want to go settings, but this time around we're not going to need to document because actually there's very few settings we have to change as opposed to making a full-on 2D only game. But nevertheless, let's go to the project settings and look for pixels per unit, because again, this sets the size on importing, how we scale our pixel art. And I found out through trial and error that 0.2 is good in this case, and this makes our pixel art 5 times as big. So let's say you have a character that is 20 pixels, instead of being 20 centimeters, it's going to be 1 meter. Next up, we want to turn off motion blur, because even though we make a 2D 3D hybrid, motion blur causes issues with animations on our 2D characters, on our pixel art characters. It usually looks very messy. We don't want to have this. And the next one I will look at is anti-aliasing. And by default, the anti-aliasing method is TSR, temporal super resolution. And for now, I don't want to change this. Actually, later we will change this to FXAA, but I want you to actually see the problems that we create using TSR. And they are not apparent right now. They're only are apparent after we change the camera settings, after we have a certain distance for a character, after they are imported. So for now, just leave this at TSR. We're going to go over this again, and I actually want to show you what happens if we just leave it as TSR. But there are a couple more settings we can do right now. So look for global illumination, and we have the dynamic global illumination method of lumen. And we can use lumen in these 2D 3D hybrids. This is totally fine. But I want to turn this off in the beginning for performance reasons so everybody can follow along. Just set it to none. And this is going to make the game run 30% faster, 40% faster. And it just makes it easier to follow along. We can actually turn this back on later, not through the project settings, but just through a post-processing volume. So we could have an option in the game where the players can select it or and turn it on or off. But by default, I think it should be off because of the performance impact, and only people with a good rig. In the same vein, let's look for reflection, and we have the reflection method. Instead of lumen, we can just set it to speed, which again is also a simpler version. And this is it for the settings. You can back out here, and next we want to import all of the assets that we're going to use in the game. As always, I prepared a package with all of the assets we're going to use as a lecture resource. So please check out the resources now and download this. And you should then get this zip file, hybrid RPG assets. It's right click, and you can extract all, extract in place, and open it up. And now you should have the paper assets, the sounds, and the UI. In the paper assets, we just have the 3 characters. So we have the guard that's going to walk around in the map. We have May, which is one of our characters that can become a follower in our team. And we have the player character Ren, which is this guy. And these, I drew all of them from scratch. It took me months to learn the art style to actually draw all of these frames. And the license for these is slightly different than for the other projects. And you can check it out under the Hybrid RPG Assets, the license. So the only thing I want to prevent is people using them for NFT and blockchain projects or for training AI, and also for redistribution and reselling these, because I need to prevent other course creators to just snatch these assets, basically save 2 months of time, and then make a course faster than me. But for you as a student, there aren't really many restrictions. You can use these assets in free or commercial projects, except for these things mentioned here. And you don't need to credit. You can just use these and yeah, do with them what you want, as long as it doesn't include these 2 points here. The UI is just something I quickly put together. So these are CC0. You can just do whatever you want. And the sounds are also CC0. I found these on opengamer.org or freesound.org. They're by various creators. And yeah, I also have a bunch of sounds here, which we're going to implement, and also a couple of UI elements. But let's start with the characters, importing the characters. And again, it is safer to not just drag the entire folder, because we have a bunch of different JSON files here. And it is usually better to create the different folders ourselves and drag them in one by one. So in Unreal Engine, let's prepare this same folder structure. So in the content drawer, we can have content, right click, new folder. I like to call this paper assets, and open it up, and then characters, new folder characters. And in here, we're going to make one folder for each character. So we have guard, another one for May, and we have another one for Ren. And let's start with the guard. Open the folder, And down here, we can do paper assets, characters, guard, and only drag the JSON. Don't select the PNG. It's going to automatically understand what to do. And just drag it in here. We can then right click and create flipbooks. And you can see we have all the animations in here. Then go to May. Same thing, we back out, May, only the JSON drag it. In this lesson, we're going to prepare all of our flipbook animations with PaperZD so we can then use them in the following lessons. And I just want to set up the animation for all 3 characters and just get it over with, then we don't have to worry about it again. We already did import the animations, right? So in paper characters, if I just go to paper flipbook, you can see we have all of these flipbooks because the JSON allow us to just create all of them with one single click. Now, first, I just want to find a basic frames per second that we want to use throughout all of these, because now you can just open up any one. It is much too fast. And I think just as a baseline, 8 FPS looks about right. So we can select all of them, right click, and if it asks you to load, yes, just load. And then go to Asset Actions and Edit Selection Property Matrix. And here select all of them and look for frames per second. And instead of 15, I just want to use 8 as the baseline. And click Save. And now you can open this up, and it looks much better, a better pace for walking. There is a problem with the idle animation though, and let's just open up the idle down for the guard. And you can see that he is constantly blinking, and there is a way to fix this. And the reason this happens is because, well, if we stop this, you can see we have a frame with the eyes open and a frame with the eyes closed. And these are the 2 frames we want to use. However, we want the eyes to be open for longer and the eyes to be closed for a shorter amount of time. And the way you can specify something like this is in the keyframes. You can click on the arrow to open it up, and we can see the index 0 and index 1. So index 0 is the eyes open, and it has a frame 1 of 1. And index 1 is the eyes closed, also with a frame run of 1. So we can, for example, put for the eyes open, put in a 20, so then it's going to be 20 times as long, right? You can see here, we now have 20 frames of the eyes open, and then we blink. And this looks much better, but I think the blinking is a little bit too fast. So we can have a frame run for the blinking of 2, and let's check it out now. And yeah, so now the blinking is a little bit longer, feels more natural, and this is just much better for the idle animation. And just using frame run is a very easy way to set this up. But now we also want to do this for the remaining idle animations for all other characters and directions. So in the content drawer, we can just still have this flipbook filter on, look for characters, and here we can just look for idle, and Control A, select all of them, right, so we have all directions and all of the animations for all characters. Right click, Asset Actions, and look for Edit Selection Property Matrix. Again, select all, and here we can look for the keyframes, and we can open up the indexes, and we don't want to change the actual sprite because this is going to differ per character, per animation, of course, but the frame run is going to be the same. So here, frame run, instead of multiple values, just type in 20 for the index of 0, and for the index of 1, just type in 2 for the frame run and save. And now we can go back here, and let's just open up a different character. So let's open up Ren, and you can see we have the same timing for the blinking, which looks very nice. One thing about the upward animation, with the guard facing upward, we can't really see the eyes, but just for the sake of keeping things simple, for keeping things the same, I do have 2 separate frames here. And this is it for preparing the actual flipbooks. And now we want to set them inside of PaperZD. So we can get rid of the search, get rid of the filter, and we go to blueprints, and we now want to create a folder for all of the different characters. So right click, and characters, go here, and then make a folder again for the guard, another folder for May, and yet another folder for Ren. And it's just very good to keep things organized because we're going to have the character blueprints in here, we're going to have the animation blueprints, and everything separately per character. Let's start for the guard. And just like last time for the dungeon adventure, we're going to start by creating the animation source. So we can right click. In this lesson, we're going to start working on the character blueprints, and a lot of the things we do are going to be similar, but again, there are some difference between a 2D only game and a 2D 3D hybrid, especially when it comes to shadows and to material settings. I again also created an inheritance chart because we're going to have different types of characters, And we do want to have everything kind of be put together in the VP RPG chart base. And here, this is just inherited from the PaperZD character. We share some settings. And this will also have things for triggering dialogue and handling interactions, which every character needs in the game. We'll then split off here and go into the VP player, which has the camera, which has player inputs like movement, and also has the action or interactions in there. On the other side, we do have the VP NPC, and the NPCs can move around using the nav mesh. They can kind of patrol the city to make it feel more alive. And they can also, of course, be talked to because they have the shared dialogue and interaction handling. And then, as a child of the NPC, we have the VP follower. And on top of everything, we have the NPC at the top of the RPG had. It can join our team, we talk to the follower, it can join our team after, and then actually follow the player walking around. And this is how we could create a party-based JRPG. Now back in Unreal, let's actually implement this, and let's start with the parent. So in blueprints, characters inside groups, we want that we share blueprints here. So we can just right click and go to blueprint class. And this should be based on PaperZD character because of course we want that be PaperZD and animation component, other functions available. So all classes look for PaperZD. And we have the PaperZD character, which is based on paper character, character font, and program. So you can get in this PaperZD character. And click select. And as we've established, I'm going to call this VP RPG char base. And this is just going to be the base parent. This is not going to be spawned in the game. This is just for our inheritance structure. And we just want to set up all of the basics here and then do the more specific things in children. So let's first open it up. And we do have the capsule here. We have the arrow, the sprite, the animation point, character movement, all of the things that we've used before. We use them again, of course. But now I want to start with the sprite. And as a stand-in on the source flipbook, I just want to select the guard, idle, and down. And this is just the default that we want to use as a stand-in and then make changes depending on the blueprint. And you can see that our pivot is at the feet, which is great because now we can just move the feet to the bottom. And you can also see the capsule almost perfectly matches the character. And this is because we already set up the pixels per unit of 0.2, making the sprite 5 times as big. And our guard character is 31, as you can see here, 31 pixels tall. So by default, with a pixel per unit of 1, it would just be 31 centimeters. But since our character is 5 times as big, it's around a meter 55, which is very realistic and close to what a regular human would be like, but also they're a little bit of a cheese style, so it's fine for them to be a few centimeters shorter. And this just makes sure that if you have a map that you buy from the marketplace, if you make a map yourself, that the characters are realistic size, they're going to fit through the doorways, they're going to look right on the stairs, and compared to all the other elements in the map. And this also affects things on the character movement component like the step height and other things we've talked about before. So you do want to make sure the characters are of a reasonable height, a reasonably realistic height. Now let's drag this character into the map to make a couple of adjustments. So go to the map, and I can just drag out the RPG character. And since this is a top-down game technically, but we don't have a top-down perspective. So we don't have to change the rotation. The character actually has to stand upright. And we want to look at it in a way that the red arrow is pointing right and the green arrow is pointing towards us. And this just means this is the frontal view. And these characters are actually drawn from a side perspective. So these are completely from a side perspective. What makes it a top-down game is that later we're going to change the camera angle to look at them from the top. And this is what makes it a top-down game. And there are a couple of things we want to change here to get that unique hybrid look. So first, on the character, we can select the character and go to the sprite, right? Select the character and click on the right side, click the sprite. And we wanted to cast shadows because now it looks very boring. Without shadows, it kind of looks detached from the world. And we just look for cast and have cast shadow here. And you can see we but we don't have a top-down perspective. So we don't have to change the rotation. The character actually has to stand upright. And we want to look at it in a way that the red arrow is pointing right and the green arrow is pointing towards us. And this just means this is the front row view. And these characters are actually drawn from the side perspective. So these are completely from a side perspective. What makes it a top-down game is that later we're going to change the camera angle to look at them from the top. And this is what makes it a top-down game. And there are a couple of things we want to change here to get that unique hybrid look. So first, on the character, we can select the character and go to the sprite, right? Select the character, and here on the right side, go to the sprite. And we wanted to cast shadows because now it looks very boring without shadows. It kind of looks detached from the world. We just look at cast and hit cast shadow here. And you can see we cast this shadow. Now, in case this is not showing up for you, you might have some different scalability settings. So in settings, under engine scalability, if you're on low, I think shadows aren't showing up. You have to be at least medium high for shadows to show up. So in case you don't see the shadow, this might be the problem. Of course, this is going to use more performance of your PC, but it's important to follow along that you see the shadows working. But the shadow is still a bit hard to see and it's kind of warm, so you want to change the direction of the sun. And we can just go here. For direction, and we can see this directional light. And this is where it is located. And we can just go to rotate mode. And then on the blue axis, here, we want to drag. And you can see that the shadow now looks longer, it looks more interesting. And usually I want the shadow to be kind of in the back and sideways a little bit so we can then see it even from this perspective. And I think this is just the most interesting look for the shadow. And this is all we have to do to make our sprites cast shadows. However, they still cannot receive shadows. And just to test this, I can click plus and just look for the cube and just select the cube. And it should be somewhere in the map now. I go to back to our movement mode, translate mode, and I can drag it up. And I want to position it so it should cast a shadow on the character, right? So this casts a shadow on the floor. It should cast a shadow on the character, but it's not showing up. And this is due to the material settings. In addition to this, the character also doesn't react to lights. So we can also go here and look at point, and we have the point light, and you can drag it up here. This, and you can see the point light, it makes the shadows change. It interacts with the floor, but it doesn't interact with the character. To make that even clearer, I can go out of this cast here, over to search, and just change the light up to red or some pinkish. And yeah, you can see that it affects the floor, so it does not affect the character. So we can change both of the issue with the shadows and the lights by just changing the material setting on the character. So get out of the search, select the character again, go to the sprite, and now down here we have the material. And this is the masked unlit sprite material. Under engine scalability, if you're on low, I think shadow owns all your PC, and this is where it is located. And you can just go to rotate mode. And then on the blue axis, here, we want to drag. And you can see that the shadow now looks longer, it looks more interesting. And usually I want the shadow to be kind of in the back and sideways a little bit so we can then see it even from this perspective. And I think this is just the most interesting look for the shadow. And this is all we have to do to make our sprites cast shadows. However, they still cannot receive shadows. And just to test this, I can click plus and just look for the
Just so you know, I'm doing stuff over here. Over here. Oh, I don't know why the directions keep changing. the input being put in twice, I wonder? Or almost not. Let's figure this out.
This is so weird.
Just select the cube, and it should be somewhere in the map now. I go to back to our movement mode, translate mode, and I can drag it up. And I want to position it so it should cast a shadow on the character, right? So this casts a shadow on the floor. It should cast a shadow on the character, but it's not showing up. And this is due to the material setting. In addition to this, the character also doesn't react to lights. So we can also go here and look at point, and we have the point light. Drag it up here. Yes, and you can see the point light, it makes the shadows change. It interacts with the floor, but it doesn't interact with the character. To make that even clearer, I can go out of this cast here, over the search, and just change the light bulb to red or some pinkish. And yeah, you can see that it affects the floor, it does not affect the character. So you can change both of the issue with the shadows and the light by just changing the material setting on the character. So get out of the search, select the character again, go to the sprite, and now down here we have the material, and this is the mask unlit bright material. And usually for 2D only games without lights, this is what we want to use. This basically just means it is self-illuminating, so it is shown in the color that it is drawn in. But now we want it to be affected by the environment. So we just want to use the mask lit sprite material, which should be right above it. And if it doesn't show up for you, again, you want to go to the cog wheel, make sure we have show engine content and show plugin content enabled, and then you should be able to select the mask lit sprite material. And you can see the light is now affecting the character, right? So this is working. Now we can get rid of this, delete the light, and you can see also the shadow sprite material. And you can see the light is now affecting the character, right? So this is working. Now we can get rid of this, delete the light, and you can see also the shadows are now working on the character. So this kind of merges the 2D and 3D elements and kind of makes them fit together and not look out of place. And now we can get rid of this block again. But the thing is that we only set up these settings in this instance of the RPG character. To really affect all of the characters that we're going to spawn later, that we're going to drag in later, we need to change these settings on the blueprint. So here inside of the blueprint on the sprite, again with the cast shadow, turn it on, and we can then go for the material, and instead of the mask unlit sprite material, we want to use the mask lit sprite material, and compile and save. And this just makes sure if you drag a character out again, if you spawn a character, all of these settings are shared between all of these characters instead of just doing it on instance, this one instance in the world. Next up, we do want to align this character perfectly to the ground. And we can just zoom in and kind of see what this looks like. And now we are very far away from the ground, you can see, and we can just make some adjustments here. So on the sprite, I can just zoom in here a bit more, select the sprite and just drag it down one more. So I'm at minus 90 now, minus 90 on the Z. Let's look here. And this looks decent enough. It's not perfect, right? We can see But if we zoom in here, that some of it is sticking into the floor. But what is much more important is that we want to worry about the side view because now with the frontal view, the side view is actually a bit more complicated. So here in the sprite, let's now select the guard idle right. And if I go back here, you can see that, well, the right foot is almost perfectly aligned while the other foot is floating. But this is actually the way it is in all of these games that if you have the side view that there's a 1 pixel difference, and I actually analyzed all of the other games that use this art style have this 1 pixel difference on the side view, and we're going to apply the same solution. Having a like float creates this gap, which is very nasty. It's going to look weird on the shadows, but actually it doesn't look too bad if you're very far away, right? So it's nothing to worry about too much. But the way they fix this is to, instead of having something float, they actually bury the first pixel almost completely in the ground because having it buried is better than having a floating element. And that's actually the way they do it in the games. And the easiest way to set this up correctly is to, well, in the world, again, select the character, go to sprite, and we can then set this snapping not to 10, but to 1. Set the snap size to 1. And then here, zoom in and select the sprite, and then we can drag it down in smaller increments. And I think, yeah, like this is perfect. So we have a very, very small gap. We show a little bit of the last pixel, and I think this is correct. So we can now look at this value. So it's minus 93, and we can copy this because now, well, we only apply this again on this instance of the character. We want to go to the blueprint on the sprite, and for the Z instead of minus 90, paste this in, minus 93. And now we have this nice thing where, well, 1 pixel is almost buried, but we don't have this gap, and this is how these games solve the problem. And now in the blueprint, let's switch back to the downward idle. So guard idle, yeah, and it should still look fine, right? So we are almost buried the first pixel, this is totally fine. Now that the base is set up, let's make another class, and this is going to be BP layer. You can right click again the RPG char and create chat blueprint. This is going to be BP NPC. And based on the NPC, as we've established, we want to have the BP follower. So here, right click the BP NPC, create chat blueprint class, and call BP follower. And let's just set the default sprite in all of these. So in the BP player, instead of the guard, we're going to go to sprite and look for ren idle. Yeah, this is fun because we have the guard, and the BP follower should be May sprite, but for May idle down. Yeah, and we're going to take care of the rest later, but we take care of the blueprints available. Now we do want to set the character to spawn though. So this guy, we can just delete him, select this guy, hit the keyboard, and we want to go to our game mode as we've done before, blueprint GMRPG, and set our player class. So for the default pawn class, not the default pawn class, we want to pick the BP player. And your view might be different. You might have this whole thing open. And then again, here, default pawn class, you just want to select the BP player. And we did set up this game mode to be the default. So this should already be set. So we can save, compile, actually make sure to save all. We don't lose any progress. If I start the game now, well, we are in this weird first person view. We don't really see anything. And if I want to get the mouse cursor back, I can hit Shift and F1, get my mouse back and eject. And I can then move around, and you will see that we actually spawned the correct character here. We spawned the correct character. This is working. We just don't have the camera and movement set up yet, and that's what we're going to do in the next videos. In this video, we're going to set up the player camera and also the movement for the player. The camera and spring arm will not be the RPG charge, so just open up the BP player, and we can go to the capsule component, the most top element, and look for spring arm. And while we have the spring arm selected, save, go into the game, and yeah, so now this looks like these hybrid RPG games. There's of course going to be other things like the POV and other effects that are going to make it look even more like it, but this is just the start. Now though, we want to back out and make sure that the inputs are working first because, well, we still can't walk. There are no inputs for the characters, and this is something we've done before. So in the content drawer, go to content, right click, create a new folder and call it input. Inside of this, right click again in the folder actions, and we're going to start by creating our first action. And for now, we're only going to set up the movement action. The interact actually we're going to take care of later. So right click here, look for input, and we have the input action. So this is going to be again IA move, open it up. And as we've done before, the value tag for this is an axis 2D because we have the x-axis, we can go left and right, and you have the y-axis for going up and down. So axis 2D is the correct one. And now we also want to back out here, go to input and create the input mapping context, input again, and have the input mapping context. And I'm going to call this IMC underscore RPG and double click, open it up. And in here for the mappings, we just want to open this up and only add the item move for now, and then set up all of the directions as we've done before. And if you're already confident you can do this, you can try it on your own. It's going to be the same as the last times, but you can also just follow along with me. Again, by default, axis 2D goes to the right, so I can just click here and set up D. For D, you don't need any modifiers, you don't need any triggers, this is fine. And then again, and next I want to do A, and A is left, so here we just need the modifier of negate, and negate. The next, I want to add S for downward, and here we just need the swizzle modifier, swizzle input axis values modifier. And then lastly, we have up, which is W, and this is in the negative direction. So modifiers 2, run of 2, we want to swizzle the input axis value, and we also want to negate this. And this just makes sure that if we press D on the x-axis, we get a value of 1, A, we get a value of -1, And for the y-axis, S gives us a value of 1, and W gives us a value of -1, which we can then use for the input. Now back only in the DP player, we need to initialize it. So on the event graph, on begin play, we want to get controller, right click, get controller, pass to layer controller, and connect these lines for sure. And then you want to get the subsystem, so get enhanced input local player subsystem. And here we want to add mapping context. And make sure to connect to this from the execution code. And then here, very important, we need to select our IMC RPG. And this is all we have to do to initialize this. Then we can compensate and set up the actual movement. So down here, we can right click, go for IA, move, and we want to use the action event, not the value, the event, D. For D, I'm going to call this IMC underscore RPG, and double click to open it up. And in here, for the mappings, now that we want to back it down, right click, for the pack that we're going to take move, open it up. And as we've done before, the value tag for this is an axis 2D because we have the x-axis, we can go left and right, and with the y-axis, we're going up and down. So axis 2D is the correct one. And now we also want to back out here, go to input and create the input mapping context, input again, and have the input mapping context. And I'm going to call this IMC underscore RPG, and double click to open it up. And in here, for the mappings, we just want to open this up and only add the IA move for now, and then set up all of the directions as we've done before. And if you're already confident you can do this, you can try it on your own. It's going to be the same as the last times, but you can also just follow along with me. Again, by default, axis 2D goes to the right, so I can just click here and set up D. For D, you don't need any modifiers, you don't need any triggers, this is fine. And then again, and next I want to do A, and A is left, so here we just need the modifier of negate. And negate, the next, I want to add S for downward, and here we just need the swizzle modifier, swizzle input axis values modifier, and then lastly we have up, which is W, and this is in the negative direction, so modifiers 2, we want a 2, we want swizzle, the input axis value, and we also want to negate this. And this just makes sure that if we press D on the x-axis, we get a value of 1, A, we get a value of -1, and for the y-axis, S gives us a value of 1, and W gives us a value of -1, which we can then use for the input. Now back only in the DP player, we need to initialize it. So on the event graph, on begin play, we want to get controller, player, pass to layer, controller, lines for sure. Then you want to get the subsystem, so get enhanced input local player subsystem, and here we want to add mapping context, and make sure to connect to this from the execution code. And then here, very important, we need to select our IMC RPG, and this is all we have to do to initialize this. Then we can compile and save and set up the actual movement. So down here, we can right click, go for IA move, and we want to use the action event, not the value, the event, and we open it up so we have access to all of these different inputs and outputs. And this is going to be the same thing we did last time, right? Spawn trigger, because we want this to happen on every frame, add movement input down here. This, and it's going to be roll direction of 1 for the x-axis. And here we can split or break the action value. And this is our x-axis, right? So this is going to give us a 1 to match this, or -1 to invert it. And then we can copy paste the add movement input. And here we don't want the x of 1, we want the x of 0, and the y of 1 to go up and down. And then just plug the y value into the scale value. And this is very simple. This is something we've done before, and it should just work as it is. Go here, and I press S, I go down, I press W, I go up, I press A, I go left, I press D, I go right, and I can also go diagonal. So this is how we set up the movement. And it works just the same for a 2D 3D hybrid as it does for a 2D only game. For now, though, we're still not switching to the run animation, we're still not switching directions of the animation, and that is something I want to take care of in the next video. However, I want to do something different in this video first, which is more important to set up first. You may remember in the dungeon adventure that we had this collision box that moves together with our rotation, that moves together with our position. And we again want to set it up so that the entire character rotates instead of only rotating the sprite through PaperZD. And this just allows us to interact with characters in front of us instead of having the solution in Monster World, where in the first project, where we just talk to everybody in our vicinity. We want to have this kind of precise collision box that moves with us. We could then also attach particle effects, everything to the character to move correctly with the character, to rotate correctly with the character. And I want to set this up now. So first in the BP player, I want to go to the viewport and I want to set up an interaction box that we're going to use later. So select the capsule component, the top level, and with the box, and with the box collision, which we want to use. And I want to call it interaction check, and then go into translate mode, move it to the right a little bit, and then make it bigger. So I can just, let's say 45, and 45, and also 45, and then just have it kind of in front of the character so I can talk to somebody who's in this distance to my character. And very important, it should be to the right because this is the default direction the character is going to look. So it should be to the right of the character for now. And we do want to see this in the game. So while we have the interaction check, we look hidden, hidden game, uncheck this, get out of the search, and now you can see here. I walk around and it's always to the right side. It doesn't really rotate with the character, and that is what we want to set up now, as we did for the last project. So back again in the BP player, let's go through all of the settings that we need. And the thing with rotating the entire character is something we actually don't just want to set up in the code. We want to set this up for everybody because, well, we might use it. So let's do it in the BP RPG chart base. So here we can just select top level and look for orient, rotation towards movement. Yes, just check this. And again, it tells you it's going to fight with other settings. So we need to get rid of the other settings. So we can look for controller yaw and use controller yaw rotation. No, turn this off so the two settings don't fight against each other. And now we want to make sure the character rotates faster. So rotation, great. And look for orient, rotation towards movement. Yes, just check this. And again, it tells you it's going to fight with other settings. So we need to get rid of the other settings. So we can look for controller yaw and use controller yaw rotation. No, turn this off so the two settings don't fight against each other. And now we want to make sure the character rotates faster. So rotation, great. And we have the rotation rate of 360 here. So this means it takes an entire second to rotate, which we don't want. And well, we can just type in 360 times 100 to make it a really high value to get instant turn. Get out the search, and well, we can try it now. And some things are working, right? We are rotating, but there's still a lot of issues. And we fixed these last time, and we're going to fix them again this time. So in the RPG chart base, well, we want to make sure the sprite rotation is world. So the sprite doesn't rotate together with the parents. Save. The same for the spring arm, but the spring arm is on the player only. So BP player, we have the spring arm rotation is world. Compile, save, and in here you can see it still looks the same. It's fine here. And now we can go to the game. I can start, and now the box is gonna go together in the direction of movement, and this is gonna match our PaperZD rotation later. So I can go down, up, diagonal. All of this is working now, and I just wanted to get this out of the way first, so we can then have more precise interactions. And now on BP player for the interaction check, I can just look for hidden game and just enable this again. Just so, yeah, because we don't need to have this visible right now. And yeah, this is it for the movement. This is for the rotation. And in the next video, we're going to take care of animations. In this video, we're going to PaperZD animation blueprint for all of our key characters and decide between the walking and idle animation and set up the correct directions. And I want to start off with our main character, Ren. So go here, from the drawer, the blueprints,
What's up,
characters,
Bob?
Ren. And inside of here, where we have the animation source, I want to right click, go to Paper ZD, and then create an animation blueprint, a Paper Z Anim E. And I want child hidden insert out this, that we set direction out. This is going to work just the same way. And you can see that it works, right? Then the same for May. So in the player, ABP May, go in. In this video, we're going to import one of the permanently free maps from the Unreal Engine Marketplace because this allows us to better understand how the field of view setting, depth of field, and other post-processing settings are going to work with our game. So first, I want to show you how you import a free map and then how we can use it in the game. Currently, to do this, we want to open up the Epic Games Launcher and go to the Marketplace. And then once that the new Marketplace is released, these steps might slightly change, but it's still going to be the same in concept. Then we can go to free and select the permanently free collection. So all of these maps and assets should always be here for everybody to use. Now, if we habits like these, we generally don't want these realistic looking maps, but we look for hand-painted maps like this or stylized maps like the Eastern Village in Egypt. Currently, the stylized Eastern Village is at the top of this collection, and this is the one we want to use. If it doesn't show up for you here, you can just look for search product and look for the stylized Eastern Village. But yeah, it is showing up for us here as well, so we can just select it either way. And first, it's going to say free. You can click on it, add it to your shopping cart, and then attach it to your Epic Games account. And after you've done that, it's going to work a little bit different than the PaperZD plugin because the plugin is installed in engine version where this map is installed to a project. So after you've registered it, we simply want to click on Add to Project, and then we want to select our hybrid RPG. This is the project we've been working on, and just click on Add to Project. And you actually don't have to shut down the underlying project. This even works while it is open. And it's going to take a couple of seconds or maybe even a couple of minutes to download the map and add it to the project. I already had it downloaded, so I just had to add the files, which is really quick. Now back at the Unreal Engine project, in the content drawer, you should have this Asian Village folder, and this has all of the blueprints, the maps, materials, meshes, and everything that is used for this map here in the folder saved now. A lot of these assets come with two different maps, and you see we have the Asian Village demo, which uses the assets it comes with to make a small level, which we're going to use, but they often also have an overview map, so let's just double click to check it out. And this might take a couple of seconds or minutes. And now the assets are loaded, the shaders are loaded, so the next time we open a map using these assets, it's going to be a lot faster. And this is just an overview of all of the different meshes and textures and materials that are going to be used in the map. And you could then use these building blocks to extend the map to make a completely new map from scratch. And yeah, so this is a modular asset pack. But we don't want to make a new map. Of course, we don't have the time for that. I'm not a level designer either, so I usually use maps, the demo map that comes with them, and then just make adjustments to them, and that's what we're going to do. So in the content drawer, we want to open up the Alien Village demo instead, and this gives us a map, a blank space that we can already use. Some of the shaders are still preparing, right? So it's going to take a couple of seconds for the materials, for the colors to all be final. But yeah, so this gives us a village. This gives us a full map. It has landscapes. It has a small forest here, right? And we can go into the city. There's statues, a couple of buildings. And like I said before, because we have the correct pixel per unit settings, our characters can nicely fit into these doorways and work with this new map. Now, there might be a couple of errors you get in here, right? So we get a warning here, and it says landscape actor with physical material needs to be rebuilt. So we can just click on rebuild, and this is just going to take a couple of seconds. And then we got rid of the error message. And we can just have a look at the frames per second. So we can go here, show FPS. And it's probably going to be a lot lower than it was in the map before because, well, we have to render all of these meshes to all of these kind of things, and it's going to impact performance. And in my case, it's running at roughly 60. Well, because I'm recording, usually it runs a lot faster, but recording uses a lot of processing power of my PC. And yeah, so I understand some of you might not have the best PC. You might have trouble running this map. So in that case, you can just keep on following along using our map that we created. You can implement most of the things that we're doing here also in the map playground if you have trouble running this map. But of course, if you want to follow along in a better way, you can just use the same map. Even if you drop to like 30 FPS, you should still be able to follow along. You could make some adjustments here in the engine scalability if you have trouble running this map as well. And now I could just type the frame rate again since we went over that. And since we set up our characters and everything as blueprints, since we set up our game mode, even on this new map, if we press on play, we do spawn a character and everything still works the same way. There's one problem though, and this is, well, we're not really facing the direction that we want in this map. We do want the character to kind of face in this direction, the camera to face in this direction, and basically have this be the x-axis, right? Have this be the world x-axis and this the y-axis. So it is going to be different than it is now, because now, well, this is the y-axis and this is the x. Now there are ways you could change the input in the player, right? So in the BP player, we have the event graph and we have a hard-coded x-axis and a hard-coded y-axis. So you could do things like get active forward direction and all of these kind of things. I experimented with those, but it is very complicated. It's usually not worth it. And I do like having a fixed x-axis, a fixed y-axis, because it makes so many things just so much simpler if you can use it. So to fix this problem, I think the better solution is to just flip the entire map by 90 degrees. So what I want to do now is to set this rotation rate not to 10 degrees, but set it to 90 degrees so we can go in a single step. We don't have to click 9 times, because, well, here on the right side, I want to hit Control A, grab everything in the map. These are 3,000 actors, which we're going to flip at once, right? And I go into rotate mode, and I drag on this blue line, and I drag to the right. And it's going to freeze up a little bit. That's going to be fine. I'm going to keep dragging until it freezes, and now I went by one step, by 90 degrees. I let go, and it's going to take a little while to update this, and yes, now I can zoom out, and I can start the game, and we are now looking in the correct direction. So I flipped the entire world by 90 degrees. And depending on what map you're using, the value might be different, but I think this is just an easier and better solution than having a whole complicated thing within the character blueprint. Now I can just click anywhere to get rid of the selection, and then just set the rotation rate back to, let's say, 10 degrees the way it was before. And you can see our character is now also facing upward towards the city, which I think is a good way to start in this case. And now just make sure to save all, so we don't lose our changes. And well, so this is the base, right? So the base we set up now could be used for any 3D hybrid. It doesn't have to be an RPG. You could use this for a beat 'em up, you did something else done. You could use this for a Metroidvania. You could use this for a platformer. The possibilities are endless. So right now we only set up the art style basically. And usually you would use this for RPGs, but there's like so much room for exploration that nobody has really looked at yet, and so many other genres that could benefit from this art style. But now I just want to set this as the default map. Again, if you have trouble following along on this map because your PC isn't good enough, you can follow along. You can keep on doing most of the things to do. But if you don't have any issue doing this map, just follow along with me now and set this as your default map. So go to product settings, go to maps and nodes, and you can collapse this here, the nodes, and just here for the startup map, we want to look for Asia, Asian village, and here also Asian village demo. And this just means if the editor crashes, if we restart, we just start in this map again, because this is the one where we actually want to implement our gameplay. And in the next couple of videos, we're going to look at the camera distance, anti-aliasing, field of view, all of these cool things that are going to make the game look much, much better. In the last video, we set up the map, and we also confirmed that our camera looks fine. So there's many RPGs which have this type of camera, but I do want to take it to the next level and use this kind of diorama miniature look that some of the recent games using Unreal Engine have popularized over the last 5 to 10 years. And to achieve this, we can use the field of view setting and also depth of field, which we're going to cover in this video. This basically makes the world look like small toy pieces or doll houses, and it is also often called a tilt shift effect. And the first part of that is setting up the field of view and the camera distance. To get instant feedback on what different field of view settings look like, we can just start the game. Make sure to not click into the viewport. If you click in, just press Shift and F1 to get your mouse cursor back. And here on the right side, you can then select our player, BP player, and you can select the camera here, and you can see the field of view setting here. And by default, it is 90 degrees. Now, field of view is also a concept that exists in photography and filmmaking. So if you have any experience there, you're probably going to be familiar with it. And many games will allow you to adjust the field of view. So a higher field of view lets you see more of the world, where a smaller field of view lets you see less of the world. So many FPS games will allow you to set this to, let's say, 120, and you can see more of the world, right? You have a wider field of view, and this gives you a competitive advantage because you can see enemies outside. But what we want here is actually the opposite. right? Because now the buildings, everything looks bigger. We want to have the opposite where the buildings and the world looks smaller. And this kind of depends on your preference, right? We could do something like 60, and you can see we're very zoomed in. So to compensate for that, we actually have to zoom the camera out. So on the spring arm, we can go to the target length, and let's say 3500, and it zooms us out. But now this is still a little bit too far, but you can see the buildings and everything appears smaller. So back on the camera, I don't want 60, I think I want 40, and we can press 40, and yeah, I think this gives us the right effect. This gives us the correct field of view. And I can just look back into the viewport and see instantly what it feels like in the game. Right, I can walk around, and you see some slowdown because I'm recording right now. But yeah, I can walk around here in the world, and you can see that also the character fits nicely into these doorways, right? Because we have the correct pixel per unit setting, it doesn't look out of place in this world, and we have a nice distance here to everything. And you could play around more with the FOV setting, with field of view. I think something between 30 and 60 is acceptable, and then adjust the spring on target arm length and to fit that number. And another thing you might notice is that the camera kind of zooms in if something is blocking our view. And this can be very helpful, but in games like this, we usually don't want this. We don't want the camera to just start zooming in. We always want it to be a fixed distance. And this is also very easy to fix. So shift F1 to get back to our mouse cursor. And in the spring arm, we can look for dual collision and disable do collision test. And now if I go back in, I can walk here, and then the camera's not going to zoom in. We can't see our character, but this is actually kind of typical for these kind of games. In some instances, we're going to create a see-through material so you can see the character behind objects, but sometimes it just also doesn't let you see the character, and it's just part of the game practice. And all of the settings that we changed now, well, we need to change them on the blueprint, not just on this instance. So we need to remember, right? We did the blueprint test, we remove this. We have a type 300 of 3500 and an FOV of 40. So let's just exit out, go back to the player, and spring on, regular for do collision, we'll do collision. Let's get rid of this and target arm length 3500. And then on the camera, look for FOV, field of view, and I like 40 for this. And now I start the game, and all of these settings are applied. Now, if you have good eyes, you might have noticed another issue. If the character is blinking, you can see some ghosting, right? So it kind of looks like there's two animations playing at the same time, they're kind of overlapping. And it's even more apparent if I'm walking around. And I'm actually going to zoom in here so you can see that better, right? So we create ghosting, and this is due to the anti-aliasing setting. Because before I said we actually want to change this, but I wanted to actually see this problem. And this is, of course, something we want to get rid of. And we can easily just go to project settings, edit project settings, and look for anti-aliasing. And by default, I say again, temporal super resolution. And the temporal part means that it uses previous images from the frame buffer, and this can create ghosting, this can create artifacts like we're seeing right now, especially with pixel art animations. And a method that doesn't have this issue is FXAA. So this is fast approximate anti-aliasing. And to my understanding, it doesn't really use something like the frame buffer. It just creates it in a different way, which is very lightweight, but it is not as detailed for 3D models. It is not as good for 3D models as the TSR is. However, we get the benefit of not having the ghosting on pixel art, which is more important, much more important. So we can just select the FXAA for anti-aliasing, and go back to the game, and I started now, and you can see if he's blinking, there's no problems, no ghosting, and also when I'm walking around, there is no ghosting, no problems, right? So we can still use anti-aliasing because in this case, we do want it for our 3D objects to have smoother edges, to have smoother lines, and not have jagged lines, but at the same time, we don't want method to interfere with our pixel art. And just to expand upon this, with Unreal 5.4, we got a new material setting called Has Pixel Animation, and this is supposed to counteract ghosting when using TSR. It was not made specifically for pixel art, but it was rather made for these scrolling kind of effects. However, I thought it would also work for pixel art. Sadly, it doesn't work for flipbooks, it doesn't work for pixel art the way that I was hoping, and it is still the best bet for us to now use FXA. There might be some changes to this later down the line that make it viable, but for now, just keep on using FXA as the best method. And this is it for the anti-aliasing, for the camera distance. In this video, we're going to adjust some post-process settings to make the game look even nicer, and then also add the depth of field for this tilt shift effect. Let's start with the easy parts first. And this map already has a post-processing volume, so we can look for post-process. And you see this map already has a post-process volume, which the artist that created this map put in here. And we can click on this eye to deactivate it, and you see that it kind of saturates the scene. It has some color grading and a couple of things that just make the map look nicer. In some cases, your maps aren't going to have this, and you can just create a new one here, right? As we did before. You can just look for post process, drag one in here and do your own settings. But I think we're going to use the one that already exists as the base because it does make the game look more vibrant and look nicer. The first thing I want to slightly adjust is the vignette because this is also part of this tilt shift effect. So while we have the post-process volume selected, I can look for vignette, and you can see the vignette intensity is 0.4, and you can see I can drag around here, and the edges of the screen kind of become darker. And this is of course too much. 0.4 is actually quite close to what I want, and I just want to go for 0.45 to make it slightly stronger. Another one that is very important is bloom. You can look for bloom, and you can see the bloom intensity is already at 1.6 by default. And just to show you, I can drag around here, but not much changes because we don't really have that many light sources. I think the only light source we have is the skylight and the directional light, the sun. So you can just see things become kind of softer, a little bit more glowy, and this is nice, but I think 1.6, which was already set up, is actually a nice value. We don't have to overdo it, but just if you want to make that adjustment, maybe a night scene, and you might want to use a couple of different values here and play around with them. And next up is the big one, which is depth of field, and this is going to make a huge difference. This will make certain areas in the world sharper and other areas more blurred out, so it allows us to kind of have the player focus on what is in the middle. So the character should be in focus, and then things that are in the background that are in the foreground should be blurred out. So in this case, we want to blur out this rooftop, right, to take the player's focus away from that and focus on the player character and things like that. And this can also very easily be set up in the post-process volume. Alternatively, you could also set it in the camera, but I believe the post-process volume makes more sense in this case. So here, instead of bloom, we can just look for depth of field. And well, we're going to ignore mobile depth of field because now we don't make a mobile game. Mobile depth of field actually uses a different depth of field method, but now in Unreal Engine for console games, for PC games, we use this down here, which is the cinematic depth of field. And there are a couple of settings here that we want to look at. Some of these just have a very minor impact, but the most important ones are the aperture f-stop, and we can actually drag this here to make it a bit bigger. The sensor width is also very important, and then also the focal distance. So these are the three settings that we're mostly gonna look at. First, to see any changes, I want to set the sensor width to something quite high. So let's type in 600, which is a little bit of an unrealistic value when you look at real photography, but I found it works nicely. And this alone didn't do anything. We also need to change the focal distance. So I can just drag this around and you can see that everything is blurred out now. And then as I drag this around, you can see that different areas are in focus. And this is of course something that we want to be similar to the distance to the character, from the camera to the character, because we do want the character to mostly be in focus. But for now, let's just set it to 3000 for testing. And I want to position myself, let's say here, so that the ground here is in focus. And now we can see what the aperture f-stop does. So a bigger value here creates a wide depth of field. So this means more things are in focus. And a smaller value creates a narrow depth of field, meaning that less things are in focus near the focus area. And these are basically the three values that we're going to play around with. For now, set the aperture to 2.5. So we start with 2.5, 600, and 3000, and we're going to make adjustments to these. Now, getting the right distance is a little bit tricky because it actually is not the same as the target arm length. So on the spring arm, we can see the target arm length is 3500. It's going to be something close to this, but not exactly because, well, we are kind of at an angle. And the best way to visualize the distance that we need is to drop the character into the map. So we can go to our config drawer and blueprints characters. We have BBP player and just drop it into the map. And we then want to kind of pilot the camera to then get a preview of what it's going to look like. So while it's selected, I can just right click and I can pilot BP layer to look through the camera. And now on the left side, we have this menu. I could go back out of this, but for now, I just want to view the world through what the camera is going to be like. We can kind of visualize where the focal plane is at too if we go to show, and at the bottom we have visualize, and we have the depth of field layers. And this is going to make it very easy for us to get the correct distance. So now you see we have the focal distance of 3000 and the aperture f-stop is 2.5. And I now want to go back to the post-process volume, and down here, where's the focal distance while I'm searching for depth of field, I can just drag this around and you can see how the planes kind of change. And the dark area, the black area is completely in focus. The green area is the foreground that is getting blurred out, and the blue area is the background that is being blurred out. And I can see that, well, a value between 3500 to 3600 looks about right. So I want to use, let's say, 3550. Actually, 3500 exactly as the target element looks the best here. And now we just confirm the focal distance is correct. We can go show and visualize. Here, visualize and get rid of the depth of field layers. And you can see that the character is now 600, and we put the character into the map. So we can go to our content drawer and blueprints characters. We have the player and just drop it into the map. And we then want to kind of pilot the camera to then get a preview of what it's going to look like. So while it's selected, I can just right click and I can pilot BP layer to look through the camera. And now on the left side, we have this menu. I could go back out of this, but for now, I just want to view the world through what the camera is going to be like. We can kind of visualize where the focal plane is at too if we go to show, and at the bottom we have visualize, and we have the depth of field layers. And this is going to make it very easy for us to get the correct distance. So now you see we have the focal distance of 3000 and the aperture f-stop of 2.5. And I now want to go back to the post-process volume, and down here, where's the focal distance while I'm searching for depth of field, I can just drag this around and you can see how the planes kind of change. And the dark area, the black area is completely in focus. The green area is the bottom will visualize, and we have the depth of field layers. And this we can just look for depth of field. And well, we're going to ignore mobile depth of field because now we don't make a mobile game. Mobile depth of field actually uses a different depth of field method. But now in Unreal Engine for console games, for PC games, we use this down here, which is the cinematic depth of field. And there are a couple of settings here that we want to look at. Some of these just have a very minor impact, but the most important ones are the aperture f-stop. And we can actually drag this here to make it a bit bigger. The sensor width is also very important, and then also the focal distance. So these are the three settings that we're mostly gonna look at. First, to see any changes, I want to set the sensor width to something quite high. So let's type in 600, which is a little bit of an unrealistic value when you look at real photography, but I found it works nicely. And this alone didn't do anything. We also need to change the focal distance. So I can just drag this around and you can see that everything is blurred out now. And then as I drag this around, you can see that different areas are in focus. And this is of course something that we want to be similar to the distance to the character, from the camera to the character, because we do want the character to mostly be in focus. But for now, let's just set it to 3000 for testing. And I want to position myself, let's say here, so that the ground here is in focus. And now we can see what the aperture f-stop does. So a bigger value here creates a wide depth of field. So this means more things are in focus, and a smaller value creates a narrow depth of field, meaning that less things are in focus near the focus area. And these are basically the three values that we're going to play around with. For now, set the aperture to 2.5. So we start with 2.5, 600, and 3000, and we're going to make adjustments to this. Now, getting the right distance is a little bit tricky because it actually is not the same as the target arm length. So on the spin round, you can see the target arm length is 3500. It's going to be something close to this, but not exactly because, well, we are kind of at an angle. And the best way to visualize the distance that we need is to drop the character into the map. So we can go to our content drawer and blueprints characters. We have the BP layer and just drop it into the map. And we then want to kind of pilot the camera to then get a preview of what it's going to look like. So while it's selected, I can just right click and I can pilot BP layer to look through the camera. And now on the left side, we have this menu. I could go back out of this, but for now, I just want to view the world through what the camera is going to be like. We can kind of visualize where the focal plane is at too. If we go to show, and at the bottom, we'll visualize, and we have the depth of field layers. And this is going to make it very easy for us to get the correct distance. So now you see we have the focal distance of 3000 and the aperture f-stop of 2.5. And I now want to go back to the post-process volume and down here, where the focal distance, while I'm searching for depth of field, I can just drag this around and you can see how the planes kind of change. And the dark area, the black area is completely in focus. The green area is the foreground that is getting blurred out, and the blue area is the background that is being blurred out. And I can see that, well, a value between 3500 3600 looks about right. So I want to use, let's say, 3550. Actually, 3500 exactly as the target element looks the best here. And now we just confirm the focal distance is correct. We can go to show and visualize. Here, visualize and get rid of the depth of field layer. And you can see that the character is now perfectly in focus. However, everything around it is blurred out too strong. The blur is too strong, actually. Next, I want to adjust the sensor width. So we set it to 600 to make it very obvious what's set. Go to F11, hit on F11, and then just walk around here to again confirm. I think we hit some nice settings here. This is a little bit of a strong depth of field, which I like, but again, some people don't like it this strong. And lastly, we can just remove this play blueprint. System. So first, I want to keep the event graph, and below the IA node, we just want to right click and look up. Now that we pretty much nailed down the look of our game, and next I want to start working on NPC interactions, which are going to be through an interface. This is somewhat similar to what we did in the first course, but we're going to expand upon it and make it more complex.